Now let's define our sixth trigonometric function using the unit circle. A unit circle is a circle with center 0, 0 and a radius of 1. Because our radius is 1, it will extend from 0, 0 to 1, 0 along the x-axis and 0, 1 along the y-axis, negative 1, 0 on the x-axis, and 0, negative 1 on the y-axis. To define our six trig functions, we're going to use a third number line, which we call t. Now as we wrap t around our unit circle, so here we're taking this number line t, and it can be wrapped in any direction, but here we're wrapping it around a counterclockwise direction. So as we wrap t around the circle, each value on t corresponded to a point on the unit circle, and this point has coordinates of x, y. Each value of t also gives us a central angle of theta. So we're wrapping this number line around our unit circle. The point on t gives us a point on the unit circle and give us a central angle. We know our arc length formula, S is equal to r times theta. Since S is going to be our t, because we're wrapping it around the unit circle, and we know r is equal to 1, then we know t is equal to theta in radians. So t will be equal to the angle theta. Based on this information, we will define the sixth trigonometric function. The first one is sine. Sine, which is abbreviated sin. So the sine of t, or angle t, is equal to the y value on our unit circle. The cosine, or cos t, is equal to the x value on our unit circle. And this is always true, and if you cannot remember, this is in alphabetical order. So x comes before y, c comes before s, cosine and sine. Every other trig function is based on these two first trig functions. The tangent trig function, which is abbreviated tan, is equal to the sine over cosine, or simply y over x. The fourth, fifth, and sixth trig functions are all inverse of the first three. So cosecant, or CSC, of t is the inverse of sine, so it's 1 over sine. So cosecant is 1 over sine t, or simply 1 over y. Similarly, the secant is the inverse of cosine, and since cosine is x, this is 1 over x. Cotan is the inverse of tan, which is x over y. So here we have our six fundamental trig functions, which you have to memorize. They're also located in the back of your textbook, so please study this. Now we'll look at a few examples. Here we're trying to determine the exact value of the sixth trigonometric function of the real number t. As t is wrapped around a unit circle, we have a corresponding coordinates of x is equal to 12 over 13 and y is equal to 5 over 13. From our definition, we know that sine t is equal to a y value. So here the sine of t is simply 5 over 13. We know the cosine of t is just our x value, so this is 12 over 13. Tan of t is equal to y over x, so this would be 5 over 13 divided by 12 over 13, which is simply 5 over 12. The cosecant of t is 1 over sine of t, so this just is the inverse of this, so it becomes 13 over 5. The secant, the inverse of cosine, so it becomes 13 over 12. And the cotan is the inverse of tan, or simply 12 over 5. Now let's look at dividing our unit circle even into more regions. Previously we had divided it into 4 quadrants. Now we're going to divide it into 8 So now we have pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4, in addition to the first 4 portions. For pi over 4, the coordinates, our xy value, would be square root of 2 over 2 and the square root of 2 over 2. Pi over 4 is a reflection in all the other 3 quadrants. So remembering that our x value is negative in the second quadrant, we have negative square root of 2 over 2, and y is the square root of 2 over 2. Both x and y are negative in the third quadrant, so here we have negative square root of 2 over 2 and negative square root of 2 over 2. And here in the fourth quadrant for 7 pi over 4, we have square root of 2 over 2 and negative square root of 2 over 2. So now we have our unit circle divided into 8 regions. We can see from this that both sine and cosine is positive in the first quadrant, since it's our cosine and it's our sine. And we know tan is the sine over cosine, therefore all 3 trig functions and their inverse will be positive in this quadrant. So we can say that all trig functions are positive here. Here only sine is positive, so therefore sine and its inverse will be positive. Here sine and cosine are negative, and if we divide negative by negative, that makes it positive, therefore tangent and its inverse is going to be positive here. In this quadrant only cosine is positive, so here we have our common acronym, which is all students take calculus, which stands for all trig functions are positive in the first quadrant, only sine and its inverse in the second quadrant, tangent and its inverse in the third quadrant, and cosine and its inverse in the fourth quadrant. Here we're further dividing our unit circle even into more parts. Here we're dividing into 12 parts. So in addition to our 0, pi over 2, pi, 3 pi over 2, back to 2 pi, we now have pi over 6, pi over 3, 2 pi over 3, 5 pi over 6, 7 pi over 6, 4 pi over 3, 5 pi over 3, and 11 pi over 6. The corresponding xy values are given here, and all of this is located in the back of your textbook in a table. So please memorize this chart. It's very important as we move on in trig. So you need to know the angles, the divisions, and you need to know the corresponding xy value. If you know the first quadrant, basically you know the entire unit circle, because these are a reflection over here, and all you have to remember is that x is negative here, y is positive. Here both x and y is negative, and here x is positive and y is negative. We can look at a few examples now pertaining to our unit circle. Now let's look at this example of evaluating all 6 trigonometric functions for t is equal to negative 4 pi over 3. So here we have negative 4 pi over 3. Since it's a negative angle, we know this is the equivalent of 2 pi minus 4 pi over 3, which gives us a coterminal of 2 pi over 3. So negative 4 pi over 3 is the equivalent of 2 pi over 3. We know from our unit circle that when theta is equal to 2 pi over 3, the x and y coordinates is negative 1/2 and square root of 3 over 2. Since we know about our x and y coordinates, we should be able to find all 6 trig functions. We know the y coordinates, square root of 3 over 2, is our sine. So sine of t is equal to the square root of 3 over 2. We know the x coordinate is our cosine value, so the cosine of t is equal to negative 1/2. We know that tangent is equal to sine over cosine. So dividing sine by cosine, we get negative square root of 3. Cosecant is the inverse of sine, so this becomes 2 over the square root of 3. Rationalizing our denominator, we multiply both the top and the bottom by the square root of 3. We get 2 radical 3 over 3. Secant is the inverse of cosine, so this becomes negative 2. Cotan t is the inverse of tan, so this becomes 1 over the square root of 3. Rationalizing the denominator give us negative square root of 3 over 3.